The ultimate journey through our solar system, a tale of cosmic drama and wonder. Welcome, space explorers, to the most incredible story ever told, the epic saga of our solar system. I'm your guide on this mind-blowing journey through time and space, where we'll uncover secrets that will fundamentally change how you see our cosmic neighborhood. What if I told you that Earth wasn't always the safe haven we know today? What if Mars once had oceans deeper than our Mediterranean Sea? And what if Jupiter, that giant guardian in the sky, actually saved humanity before we even existed? Buckle up, because we're about to embark on a voyage that spans billions of years, revealing the dramatic forces that shaped the worlds around us and ultimately made life on Earth possible. Let's start with home, our beautiful blue marble floating in the cosmic void. But Earth's story isn't one of lucky coincidence. It's a tale of cosmic precision that borders on the miraculous. Picture this: 4.6 billion years ago, our young planet was a hellish ball of molten rock, bombarded by asteroids and comets. The surface temperature reached 2,000 degrees Fahrenheit, hot enough to melt copper. Yet somehow, through this chaos, something extraordinary happened. Earth found its perfect balance, not too hot like Venus, not too cold like Mars. We call it the Goldilocks zone. But here's what's truly remarkable. Earth has maintained this delicate equilibrium for over 4 billion years. That's not luck. That's cosmic engineering at its finest. The secret lies in Earth's size and geology. Our planet is just massive enough to hold onto its atmosphere, creating a protective blanket that shields us from the harsh radiation of space. Our magnetic field, generated by our molten iron core, deflects the solar wind like an invisible force field. But here's the kicker: this perfect balance won't last forever. As our sun continues its stellar evolution, it's gradually getting hotter. In about 1 billion years, Earth's oceans will begin to boil away. Complex life, as we know it, will cease to exist, and our once blue planet will become a scorched wasteland, much like Venus today. Eventually, when the sun exhausts its hydrogen fuel, it will expand into a red giant, potentially engulfing Mercury and Venus entirely. Earth might barely escape this fiery fate, but it will be leaving behind nothing but a barren rock, a silent testimony to the billions of years of life that once flourished here. Now let's journey to Mars, the red planet that captures our imagination like no other world. But Mars holds a secret that will shock you. It wasn't always the frozen desert we see today. 3.8 billion years ago, Mars was a completely different world. Imagine vast oceans stretching across ancient continents, with shorelines that held 10 times more water than all of Earth's Great Lakes combined. The Uranus Basin, one of Mars' most ancient features, contained a sea 3 times larger than the Caspian Sea. Here's where it gets incredible: beneath these ancient Martian oceans, volcanic vents created the perfect conditions for life to emerge. We're talking about the same hydrothermal environments where scientists believe life first sparked on Earth. Mars had all the ingredients: liquid water, chemical energy, and a protective atmosphere. For hundreds of millions of years, Mars thrived. But then, 3.7 billion years ago, catastrophe struck. Its magnetic field. Unlike Earth, Mars is roughly half our planet's size, which meant its molten core cooled much faster. When that happened, the magnetic dynamo that protected the planet shut down forever. Without this invisible shield, the solar wind, that stream of charged particles from the sun, began systematically stripping away Mars' atmosphere. The auroras that once danced above Martian poles faded into darkness. The oceans that once teemed with potential life slowly evaporated into space or froze into the polar ice caps we see today. In its death throes, Mars became volcanically hyperactive, creating floods of biblical proportions. Water cascaded down from the southern highlands, creating waterfalls 4 kilometers high. The largest waterfalls are solar. These torrents carved the spectacular canyons we see today, the last monuments to Mars' watery past. Prepare yourself for one of the solar system's most bizarre inhabitants, Uranus, a world so strange it defies everything we thought we knew about planetary formation. When Voyager 2 first encountered Uranus in 1986, scientists were baffled as ever. This ice giant, 17 times more massive than Earth, spins completely on its side. While every other planet rotates like a spinning top, Uranus rolls around the sun like a cosmic bowling ball. But the strangeness doesn't stop there. Uranus is the coldest planet in our solar system, even colder than Neptune, which is much farther from the sun. Its atmosphere is so featureless that early observers thought their instruments were malfunctioning. The mystery deepened when Voyager discovered Uranus' ring system. Unlike Saturn's spectacular rings that orbit around the planet, rings orbit vertically, like giant Ferris wheels spinning around the planet's poles. What could cause such cosmic weirdness? The leading theory is absolutely mind-blowing. Sometime during its formation, Uranus was struck by an Earth-sized object traveling at incredible speed. This collision was so violent it knocked the entire planet onto its side and blasted away most of its internal heat. This cosmic catastrophe explains why Uranus is so cold today. While other giant planets generate heat from their cores, Uranus remains a cold, sluggish world, the victim of an ancient cosmic hit and run that forever changed its destiny. Welcome to Saturn, the crown jewel of our solar system and home to one of the most spectacular sights in the universe, its magnificent ring system. But Saturn's beauty masks an incredibly violent and dynamic world. First, let's talk about Saturn's weather. Forget everything you know about Earth's storms. Saturn's atmospheric fury makes our hurricanes look like gentle breezes. Lightning strikes here are 10,000 times more powerful than anything on Earth, and winds rage at supersonic speeds of 1,500 miles per hour. But here's what's truly incredible. Saturn's weather isn't powered by the sun like Earth's climate. At Saturn's distance, sunlight is 100 times weaker than on Earth. Instead, Saturn has its own internal heat engine. Deep within the planet, under crushing pressure 80 times greater than the bottom of our deepest oceans, something magical happens. The atmosphere becomes so compressed it behaves like liquid metal. Helium rain falls through this metallic hydrogen, releasing enormous amounts of kinetic energy as heat. This internal furnace drives Saturn's incredible weather systems, creating diamond rain at depths of 8,000 kilometers. Yes, you heard that right. It literally rains diamonds inside Saturn. But even these precious gems don't survive the crushing depths, eventually dissolving under the immense pressure. Now, about those famous rings. The Cassini mission revealed that Saturn's rings are far more dynamic and complex than anyone imagined. What appears as smooth bands from Earth are actually thousands of individual ringlets, some twisted into spirals, others braided together by the gravitational dance of shepherd moons. The rings themselves tell a tragic story. Scientists believe they formed when an icy moon, perhaps 400 kilometers across, wandered too close to Saturn and crossed the Roche limit, that invisible boundary where Saturn's gravity becomes stronger than the moon's ability to hold itself together. In what must have been one of the most spectacular events in solar system history, this doomed moon was literally torn apart by tidal forces, spreading 17 trillion tons of ice debris into orbit around Saturn. Within just a few days, this cosmic debris formed the ring system we marvel at today. Our journey now takes us to the edge of the solar system, to Neptune, a world that shouldn't exist according to our understanding of planetary formation, yet stands as one of the most dynamic and beautiful planets in our cosmic family. Neptune is an enigma wrapped in a mystery. Despite being 30 times farther from the Sun than Earth and receiving 900 times less sunlight, Neptune is actually warmer than Uranus. How is this possible? The answer lies in Neptune's incredible internal dynamics. Like Saturn, Neptune generates its own heat through exotic processes in its interior. Scientists theorize that carbon from methane in the atmosphere transforms into diamond rain under the immense pressure, eventually melting and releasing energy as it falls toward the planet's core. This internal heat source drives the most extreme weather in the solar system. Winds on Neptune reach supersonic speeds of 1,500 miles per hour, faster than the speed of sound on Earth. These aren't just brief gusts. They're sustained hurricane force winds that circle the entire planet. When Voyager 2 visited Neptune in 1989, it discovered the Great Dark Spot, a storm system larger than Earth itself, with winds so powerful they could tear apart any spacecraft foolish enough to venture too close. The lack of surface features means these storms can rage unimpeded for decades or even centuries. Neptune proves that even in the frozen outer reaches of our solar system, worlds can be incredibly dynamic and alive with activity. It's a reminder that the universe is far more active and energetic than our earthbound perspective might suggest. Let's rocket inward to Mercury, the smallest and most mysterious of the rocky planets. For centuries, Mercury remained largely unknown due to its proximity to the Sun, making it incredibly difficult to observe and even harder to visit. When NASA's Messenger spacecraft finally reached Mercury after a 7-year journey involving multiple planetary flybys, It revolutionized our understanding of this tiny world. What scientists discovered completely overturned everything they thought they knew about planetary formation. Mercury is essentially a giant metal ball with just a thin shell of rock. Its iron core makes up 75% of the planet's radius, far larger proportionally than any other planet in our solar system. For decades, scientists assumed this strange composition meant Mercury formed very close to the Sun, where heat would have stripped away lighter elements. But Messenger's chemical analysis revealed something shocking. Mercury's surface is rich in volatile elements, substances that should have boiled away if the planet formed so close to our star. This discovery suggests Mercury has a far more dramatic origin story. The leading theory now is absolutely mind-blowing. Mercury didn't form where we find it today. Instead, it may have originated much farther out in the solar system, perhaps in the region where Earth formed, about 160 million kilometers farther from the Sun. Picture this cosmic drama. The young Mercury, originally much larger and more Earth-like, gets caught in the gravitational chaos of the early solar system. Something, perhaps another planetary embryo, sends Mercury careening toward the Sun. During this death spiral, Mercury collides with another world, stripping away most of its rocky crust and mantle, leaving behind primarily its metallic core. This battered remnant eventually settles into the highly elliptical orbit we see today, where it experiences some of the most extreme temperature variations in the solar system. During its day, surface temperatures reach 800 degrees Fahrenheit, hot enough to melt lead. But during its night, temperatures plummet to minus 290 degrees Fahrenheit. Mercury's story is a reminder that the solar system's formation was not a gentle, orderly process, but a violent cosmic battlefield where worlds were built, destroyed, and rebuilt in an epic struggle for survival. Now we come to Jupiter, the king of planets and perhaps the most important world in our solar system for the existence of life on Earth. Jupiter's story is one of cosmic immigration, planetary destruction, and ultimately, salvation. When Jupiter first formed 4.6 billion years ago, it didn't stay put like the well-behaved planet we see today. Instead, this massive world, more than twice as massive as all other planets combined, began a terrifying journey inward toward the Sun, acting like a cosmic wrecking ball. As Jupiter bulldozed through the primordial asteroid belt, its immense gravity scattered countless objects. Some were flung into the Sun, others were ejected into interstellar space. This cosmic rampage explains why our asteroid belt today contains less than 1% of its original mass. Jupiter's inward migration had catastrophic consequences for the developing solar system. It starved Mars of the material it needed to grow, which is why Mars ended up only half the size of Earth. If Jupiter had continued its relentless march toward the Sun, it might have prevented Earth from forming at all. But then something incredible happened. Saturn arrived on the scene. As Saturn formed and began its own inward migration, it eventually caught up with Jupiter. The two giants became locked in a gravitational dance called a mean motion resonance, and together they reversed course, moving back out toward their current positions. This cosmic ballet saved the inner solar system. Jupiter's outward journey scattered water-rich asteroids and comets inward, delivering the precious water that would eventually fill Earth's oceans. Without Jupiter's grand tour, Earth might be a dry, lifeless rock. But Jupiter's influence on Earth didn't end there. About 66 million years ago, Jupiter's gravity nudged a 10-kilometer asteroid out of the asteroid belt, sending it on a collision course with Earth. When this space rock struck the Yucatan Peninsula, it triggered the mass extinction that ended the age of dinosaurs. This might seem like a catastrophe, but it was actually a gift to humanity. By clearing the ecological stage of large reptiles, Jupiter made room for mammals to diversify and evolve, eventually leading to the rise of human civilization. Today, Jupiter continues to protect us. Its massive gravity acts like a cosmic vacuum cleaner, capturing dangerous comets and asteroids before they can threaten Earth. We witnessed this protection in action in 1994 when comet Shoemaker-Levy 9 broke apart and slammed into Jupiter's southern hemisphere, creating explosions equivalent to 6 million megatons of TNT. Without Jupiter's protective influence, Earth would be bombarded by comets and asteroids far more frequently, making the evolution of complex life nearly impossible. As our journey through the solar system comes to an end, we are left with an incredible realization. We are not here by accident. Every planet, every moon, every asteroid in our solar system played a role in creating the conditions necessary for life to emerge and thrive on Earth. Mars shows us what Earth could have become if we were smaller or lacked a strong magnetic field. Venus demonstrates the runaway greenhouse effect that awaits worlds too close to their star. The gas giants reveal the incredible diversity of worlds that can form in planetary systems, while protecting inner worlds from cosmic debris. Even the seemingly chaotic early period of planetary migration was crucial for our existence. Jupiter's inward then upward journey delivered water to Earth while clearing away the building blocks for super-Earths that would have made our planet uninhabitable. Our solar system is not just a collection of worlds spinning around a star, it's a finely tuned cosmic symphony where every instrument plays a vital part in creating the harmony that allows life to flourish. The story of our solar system teaches us that we live in an incredibly rare and precious cosmic environment. Earth isn't just the only known planet with life, it's the product of billions of years of cosmic evolution, planetary interactions, and sheer cosmic luck that brought together all the right ingredients at exactly the right time. As we continue to discover thousands of exoplanets around other stars, we are beginning to appreciate just how special our solar system really is. Most planetary systems don't have a protective giant like Jupiter, or a moon as large as ours to stabilize Earth's rotation, or the precise balance of elements that makes our world habitable. We are children of the cosmos, made of star stuff, living on a tiny oasis of life in a vast universe that is mostly hostile to our existence. But we're not just passive observers of this cosmic drama, we're the universe becoming aware of itself, capable of understanding our origins and our place in the grand scheme of creation. The next time you look up at the night sky, remember that you're seeing our solar system's family portrait, a collection of worlds that have been dancing together for over 4.6 billion years, each playing its part in the greatest story ever told. The story of how we came to be. Wow. What an incredible journey we've just taken together through our amazing solar system. From Mars' ancient oceans to Saturn's diamond rain, from Jupiter's protective shield to Mercury's violent past, every world has a story that connects directly to our existence here on Earth. If this cosmic adventure blew your mind as much as it blew mine, I need you to do 3 things right now. First, smash that like button if you're amazed by how special our solar system really is. Your likes help other space enthusiasts discover these incredible stories. Second, share this video with everyone you know. Whether it's your science teacher, your space-loving friends, or that family member who thinks space is boring, trust me, this will change their mind. Help spread the wonder of our cosmic neighborhood. Third, subscribe to BrightBoundX and hit that notification bell. We're just getting started on our journey through the universe. Coming up, we'll explore black holes, dive into the search for alien life, uncover the mysteries of dark matter, and reveal the ultimate fate of the universe itself. Don't forget to leave a comment below. Which planet's story surprised you the most? What cosmic mystery do you want us to explore next? I read every single comment, and your ideas help shape our future adventures. Remember, we're all made of star stuff, sharing this incredible cosmic ride together. Until next time, keep looking up, keep wondering, and keep exploring the infinite mysteries of our amazing universe. This is BrightBoundX, signing off from our incredible journey through the solar system. See you in the next adventure among the stars.